Good evening to all, and today we will discuss about the introduction to GIS and what is GIS and different component of GIS and which type of data are used in GIS platform and basics of GIS. So now the presentation is visible to all of you.
Presentation is visible, sir, but nobody is there, sir. Only myself is there. Can we
Okay,
wait
okay.
for some
So just
time?
wait
We can
for
wait for
5 minutes.
some more time, sir.
Okay.
Okay, sir. Hmm.
Okay, then we will start the presentation. Today we will start the basics
Okay,
of
sir. Yes.
GIS. Okay, then what is GIS? So before going to the details of the GIS details, then what is some important points are there about GIS. So GIS is the full form of the is the geographic information system. So all the information related to the geographical area or any landscape or any surface of Earth's different land resource, that is getting the information with the help of different space-based data, and some softwares are there. So based on this, the GIS is working. Now the GIS touching almost all sphere of the society, from environment to transportation, government to enterprise and the general public. So it is expanding in the large scale in different branches of the natural resource management, and therefore the understanding of GIS increasingly essential for professionals, academic practitioners, and also in for the common mass. So nowadays we use the GIS related maps in mobile phone, then in different study materials also map based study materials are there for different competitive exam, and different news channels also use the different maps of a different landscape. So GIS is nowadays very increasingly popular among all the subjects and all the domains. That's why nowadays GIS is very much important to know, and knowing the different tools and different techniques of GIS. So basically, a lot of definitions of GIS are there. So one of the example I've just mentioned, one of the definition, that is a GIS is a computer system used for capturing, storing, managing, acquiring, analyzing, displaying geospatial data. So this is one of the definition of GIS. सो इसमें क्या होता है कि जनरली जो भी जियो स्पेशियल डाटा है, जियो स्पेशियल मीन्स बेस्ड ऑन द जोग्राफिक रिलेटेड डाटा, तो उसको हम कैप्चर करते हैं, जस्ट कैप्चरिंग द डाटा फ्रॉम सैटेलाइट और फ्रॉम मैप्स, then storing data in the GIS platform in different softwares like ArcGIS or QGIS or NV softwares. So we just store the data, then managing and querying the data using different software, GIS software, then analyzing this data. So based on the our requirement, we just analyzing the data for land use and cover uh, analysis, or any road network analysis, or health GIS analysis, or any natural resource management details. So for different objectives, we just analyze all this data, then displaying the geospatial data. So we just display in the form of different PDF or in JPG in the map versions. So these are the different stages for in the GIS. So first we just capture, then store this data, then after storing, we just querying the data which is useful for us. Which data is useful, and just query the data. Then based on our objective, we just analyze this data. Then we, after analysis or processing, we just displaying the output for our requirement. So these are the steps. So this is the definition of GIS. All these GIS for work are done based on these steps. So this is the definition. It is Chang 2010 definition. Then geospatial data. So what is geospatial data? It is a geographically referenced data that describe both location characteristics of special features such as river, road, canal, land parcel, vegetation on Earth's surface. So what is a reference data? Suppose there is a map or there is a any satellite data is there. So without any reference, so we cannot use this data. So first we have to input some latitude, longitude information to this map or the satellite data in the form of georeferencing tool. So there is a georeferencing tool in the GIS software. So in this georeferencing tool, we just give the coordinate of latitude, longitude with reference to the Earth surface, and after giving this latitude, longitude information, then this data is used in our GIS system with a different coordinate system. So without giving any latitude, longitude information of any data, we cannot use this data in the GIS platform. So any data, any raster data or vector data, if we want to process in the GIS platform, it should be a reference data, any type of reference like a geographic coordinate system or projected coordinate system or different datums. So it should be within the frame of the GIS. Without this, we cannot use this data. So this is the geospatial data. So every geospatial data have some information and the exact locations like latitude, longitude, and altitude may be present or not. It is optional, but latitude, longitude is compulsory. These are the geospatial data. So a lot of geospatial data are there. We just discuss different data later on. Then so different component of GIS are like analysis, data, software, satellites. All these functions are there in the GIS platform. So we can create maps, we can analyze different statistical data or geographical data. Then different data are stored, spatial data, non-spatial data, and different softwares are there for the GIS operations, and different satellite image and different satellite data are included or used for in this platform. Then different career options are there and different apps are used. GIS maps or GIS operations are there. So these are the all different parts of the GIS. Then a lot of the times this question asked as a long question, 10 mark questions. So what is the component of GIS? Just write down in 200 or 100 words. So it is very much important question. So we will discuss all this one by one. So different component means, so total in our GIS platform, which type of works are there, which type of work we have to do. So for working in a particular work, particular projects or particular technique, so minimum requirement of the different uh, features are also included in the component of the GIS. So in the GIS component, data, so these five features are most contained in the GIS. So first is data. So without data, we cannot create any type of output. So data is very important factor. Then software, only GIS software. Then hardware, which type of hardware is there for different machinery operations. Then peoples are involved. Then methods are involved. So these are the five component. Then this is the hardware. That is the physical device to run GIS software. So uh, our hardware device must be well equipped and well updated for example, for GIS software installation. Minimum requirement is there for how much RAM is there, how much hard disk is there, and what is the graphics used for this. So more high power graphics, then RAM memory will be more for operation of different satellite data, as the satellite data are more memory used, more than 10 GB, 20 GB. That's why the RAM will be minimum 4 GB or 8 GB, and different GPS are used, GPS devices used, then printer, scanner, plotter, all the uh, features are included in the hardware. Then software part. So operating different data, we have used different GI software and remote sensing softwares are also there. So remote sensing and GIS are interrelated. So we'll discuss later. So different for the analysis and storage, visualization and output. Different softwares like ArcGIS, QGIS, GrassGIS, Aradas Imagine, NV. These softwares are used. So out of these, only open source software is QGIS and GrassGIS. But this ArcGIS, Aradas Imagine, and NV, these are the commercial software. So it cost more than 1 lakh. Then after that, then data. So there are two type of data, that is spatial data and non-spatial data. So which data are space-based informations are there, like satellite data or any elevation models, like DEM, digital elevation model. So all these are space-based data. That's why these are called as spatial data. And non-spatial data are related to the spatial data, which are not created with the in the platform of the space, like attribute data or Excel data or other related data. These are non-spatial data, but all the spatial data is integrated with some non-spatial data for getting the more information, to getting the metadata information. All these are included, so it is interrelated. And special data like maps, satellite image, coordinates, shape files. Like in AutoCAD, you use the DWG file, drawing files. In ArcGIS or any QGIS, we use the shape file in the format of .shp. Then attribute data like population data and land use data, temperature information, soil type, then different locations. So these are some attribute informations are there, including some population informations for particular purpose. Then next component is the people. People in this user who operate the GIS system. So there's a need of expert or a specialist in GIS. So this is the requirement of the people, and some users are also included who can use this GIS platform or just use these GIS layers to work in different platform. So includes the operator of the GIS system and some users and surveyors and decision makers also. So these are the included in the people. Then methods. So lot of methods are there for different operation, like techniques, different models, uh, supervised classification model, unsupervised classification model, then random forest model. So like different machine learning techniques model, different AI tools are there. So all are integrated in the GIS platform. So different models are used based on our result. So these are the methods. Then process special data include data standard, workflow, analysis model, data management protocol, all are included in the method. So generally, method is depend on the output of the result. So which type of output is required. So based on this, different models are used. Then another thing is that element of geographic information system, that is a element of GIS. So lot of elements are there. Element like some part of the work of the GIS. So we will discuss one by one. So first is the geospatial data. So geospatial data means the GIS based geographic in related data, geography related data, that is geospatial data, which are used in the GIS platform or which are used in the GIS software. So different softwares are there and for the GIS work. Nowadays we
Sir,
use,
excuse me, sir. Components and elements are not same, sir. Different, sir.
yes,
Actually, meaning is
elements
same,
are
na.
different. Elements
Sir.
are different. Components are
Mm,
fixed. We can
yes,
change
sir.
the element number, but sorry, component. The component are fixed, but elements are different. So generally, some more of the time, components of the component of GIS questions are more time asked, but sometimes elements of geographic information also asked. So elements is just uh, details about the geographic and data contents. So we just
Components, sir.
discuss the
Okay.
yeah,
Okay, sir. Thank you.
discuss one by one features. So these are some like the parameter of different GIS platform. So geospatial data. So lot of geospatial data are there. So nowadays we use the software and in open source. Nowadays Google Earth Engine is also use the geospatial data. And then now use the R programming and Python programming for using the geospatial data for different operations using different models and AI tool. So AI also use some geospatial data. A lot of geospatial data are there, like some examples are there, like so it is divided into two part: geospatial data, that is raster data, which are pixel based data, and some vector data, which are point, line, polygon form. So these two type of data are generally used in the geospatial data. So some example of the vector data, that is point, line, polygon form, is CAD file, that is drawing file, shape file, .ssp file, coverage file. Nowadays, it is not very much used in coverage file. Then geodatabase, which is very much used in the RGS software, and some raster data are most of the time the maps and the satellite data. So a lot of satellite data are used in different platform. So satellite data, raster data, then used to present physical features such as road, river, and common with the coordinate system. So all these data have latitude, longitude, and projection system. With some data have altitude informations, or some data have without altitude information, but latitude, longitude is the compulsory data for any geospatial data. Then data acquisition. So how to collect the data, where to collect the data, how much, what is the time we collect the data. So these are the factors for the acquisition of the data. The process of collecting geospatial data from various sources, like different free open source sites are there. From ISRO, there is a NRSC, and some Bhuvan site is there, and for USGS side. So different country have some free open source data are there, and also we can access the data using the Google Earth Engine. So we can download also data, some of the data from Google Earth Engine and from USGS side and from Bhuvan side of ISRO. So these are the sites we can collect the data, which are some data are geographically corrected or reference data, or some data are not geographically corrected, and IMD also supplies some data. So a lot of geospatial data are available in the different domain, and this can be used for different projects or different research purpose, or for different other works. So nowadays data is not one of the problem, but one of the negative, the disadvantages is data are available in the a small scale map. So large scale map data like high resolution data of different area, 1 is to 10,000 scale maps or 1 is to 5,000 scale related data are not available or in the open source, but it is used as a commercial purpose. This is one of the restriction to the common people. So if we have less resolution data, then where work is less accurate as compared to the high resolution data. So this is one of the constraint for common researcher or any uh, project work specialist. Then GS, GPS survey, all these are there. Then data can be collected as a surveying method. We can survey that area, then different satellite image, then cartographic studies, photogrammic method, all these collected, then vector and raster, all these are discussed. Then geospatial data acquisition in a different platform like leader generally used for the elevation information, then crowdsourcing then UAV. Nowadays it is very popular, drone based survey data. So it is very accurate and its resolution is very high. Then sonar and bathymetry. Bathymetry is generally used for the study of the depth of the ocean. So to measure the depth of the ocean, we use the bathymetry data, which are also available in the open source. Then mobile data collection. We can collect the mobile from geotagging of different locations. Then smartphone apps and sensors are also use geospatial data, aerial photography, field survey, then remote sensing, meteorological data, ground penetrating radar, GPR data also used. Then social media, web data also included in the geospatial data. Then digitizing and scanning. Uh, so digitizing the data, the geospatial data, and scanning of the different data. So these are all the features of this geospatial data acquisitions. Then attribute data management. So attribute data is related to the non-spatial data. So it collect generally spatial data like shapefile or geodatabase file have a common attribute which mm, collect all the information related to the data. So these are called attribute data. So for one features, there is a one row is created and different columns of different informations are there. So each row have one column that is FID or ID, which is a unique ID automatically created by the GIS software. So it is useful for uh, connecting with the next uh, other database files or relational uh, feature comparing. So this is the one of the picture of the attribute data of the one of the shape file. Then different data like ID, area, perimeter, type, all these information are collected, and each mm, point data. So it is a one of the point data. So each point have different attributes, different row. Each point have one row, and each row have different column. So each column has different information of a particular point or polygon or line. So likewise, the different points or point line and polygons are there. So for all these point or line or polygon, different informations are there. Suppose for I we have some water quality data in a point form. So each point have some ID, then what is the location, what is the latitude and longitude of this point of well data, and this well have how much the water depth and what is the quality of water. So all these informations are collected in this attribute data, which is a non-spatial data, which is integrated to spatial data. So these all these data, a lot of attribute informations are there for 10,000 points. So 10,000 of raw data are there. So to manage this all this data, there is a database management system is there. So suppose we want 10 information. So which well data have high chlorine content. So to find out this, we have the query builder. Query builder option is there. So in this query builder, we can filter and analyze the output. So this is called the essential for querying and filter. So in the GIS software, a lot of associate softwares are working in the hidden zone, like some database management system, like a database software is there, then C++ is there, then uh, .NET software is there, Python is also there, Python scripts are there. So lot of softwares are included in one softwares for functioning a smooth function and getting the output. Then these are the attribute informations of the spatial data. So a lot of attributes can be created in a lot of columns also created, lot of and a lot of row also created. So it is important to note that for 10 features, only 10 row are created in the attribute data. So no any extra row is created. So the 10 features signifies the 10 row of the attribute data. So in this, there are 287 selected features are there. So we confirm that there are only 287 point or line or polygons are there. So this is the basic information. Then data display. So displaying the data in the form of map, then in the form of elevation or in the form of land survey, land cover, we can display, then analyze, and we can get the output. So involve the visualization, spatial and attribute data. So generally, most of the geospatial data cannot be visualized with the non-GIS softwares. So most of the file cannot be open in other softwares. Nowadays, some programming like Python, Google Earth Engine, and our software also use the geospatial data using some tools, and some geospatial tools are there. Then support thematic mapping like population density, land cover, and a lot of thematic mapping are there. Geology, geomorphology, then uh, pollution studies, all this stuff. So we can display and visualize all the spatial and attribute data in the form of color, level, and different with the different scale. Then data exploration. So after getting the data, from the field or any different form. We just explore whether the data is georeference or whether data is wrong or right, it is corrected data or it is some missing data. We just explore, then identify some errors, then we normalize the data, then we corrected the data, then we then after we use this data. So these are some pictures where the different data are visualized, then checked whether it is correct or not. Then after with the different processing and different activities are going on. So exploring the data is one of the important factor to examining the data what is valid or not. Then data analysis. So different analysis are there, like spatial analysis. Different spatial analysis tools are there in the GIS software, like buffering, overlay, proximity. What is the buffering or overlay? So buffering is, suppose one river is there. So I want to create a polygon for 100-meter buffer. So it means a, a buffer polygon or line is created with equidistance from the reverse bank to 100-meter both of the sides. So this is the called overlay and the buffering system. So we just create a boundary with the equidistance, specific distance in meter or kilometer for different operations for flood mapping. So how the flood is affected in 100-meter distance in the river. So for this, we create the buffer, and a lot of things are there. Suppose for road, there are also buffer zone for plantation, for acquisition of the land in the railway lines. So in the line form, then in the polygon forms also there are some different operations are there. So this is called the buffering, overlay, and proximity analysis. And then network analysis is what is the shortest path to go to the different locations. Nowadays we use the Google Maps in mobiles to get the shortest distance. That is also calculated with the help of network analysis. So lot of networks are there in their database. Then in this they calculate the shortest distance with some factors, getting some factors. So that is the network analysis. Then surface analysis in the sense, suppose we have some elevation information in the form of digital elevation model or digital surface model, or any elevation satellite image is there, then we can create the slope, aspects, contour, then 3D maps. So these are all the surface analysis. So all the surface analysis tools are there. And within this, we work the slope and specs. Then temporal analysis. Temporal analysis means, suppose in the city of any Mumbai or other metro city, the different land use pattern in 2000 and the 2016. So what is the changes in the land use pattern? Mostly in the metro city, that settlement pattern is changes. So these changes are identified with the satellite image using supervised or unsupervised classification or with the help of digitizations. So these are called change analysis. So in this map, this is a map that 2010, this is the settlement area in the red zone, and 2016 it is the rapidly increase. So these are analyzed with the help of the different model also, and also using different machine learning techniques. Then this is also some dam data from digital elevation model. We can create different drainage lines. Then with the help of this drainage line, we just create different watershed boundary. Nowadays, SRTM dam is available free of cost. So with the help of this SRTM dam, we can create the stream network or watershed boundaries. Then this is the road network map to show different track and the important track are there. This is also one of the urban area where the demand points of red dots are there. So where the red dot is very much important and junction areas. So within this lot of so for mapping in the urban area, lot of informations and lot of studies are there. Field level studies are there. So based on these field level studies and inputs, we just create this map. Then historical development of GIS. So GIS, how this GIS term is used and how this historically developed and what is the beginning. So 1960s, the beginning is started. So it is from the Canada Geographic Information System developed by Robert Tomlinson's for land use planning. The first true GIS used in Canada. So nowadays also in Canada, the very advanced techniques are used in the GIS platform. So Canada is very advanced in GIS nowadays also. So basis capabilities include map overlay, spatial analysis, and data management. All these tools and techniques are developed by the Robert Tomlinson's. So he also called as the father of GIS, and he recently passes out. Then 1970s, then academic and government adopt these GIS techniques. Then Harvard Laboratory for Computer Graphics, Spatial Analysis developed like SIMAP, GRID, Odyssey, Foundation of Modern GIS. Then different government agencies like USGS nowadays also we just get the data of different spatial data in the USGS website. So different GIS platform and planning are used in the US. Then in 1980s, commercializations are happen and the different softwares are developed like ISRI. So it is from California. So full form of ISRI is Environmental System Research Institute, and that is the ISRI. In 1981, the first commercial successful GIS software. Nowadays, this is the largest coverage of the largest part of the country, like one more than 120 countries. The ISRI RGS software is used. It's a large scale used nowadays. So every government office in the government GIS cell, the RGS is compulsory. So introduction of raster and vector data models and GIS database that are integrated in this software. Then concept of special data infrastructure, SDI data started emerging. Then the 90s expansion and integration of graphics user interface based GIS software becoming common like ArcView. Rapid digitization paper maps and satellite data are ongoing. Then integration with GPS remote sensing lead to more accurate spatial analysis. Then after 90s, the growth of the GIS is gradually increases. Then after 2000, the web-based GIS and WebGIS are introduced, and a lot of web-based GIS are applied in different platforms. After this, the rise of open source GIS like QGIS after 2005 or 6, Google Maps and QGIS are invented. Then growth of mobile GIS applications, real-time data collections are also growing in the fast direction. And use of spatial data in e-governance, urban planning. After 2010, the big data cloud GIS, cloud-based GIS platform like RGS Online, Internet of Things, real-time sensor network, 3D GIS, leader integrations, and geospatial analysis in climate change modeling such there. So in 2020 to 25, So AI based, then artificial intelligence, automation, geospatial intelligence, these are included. And nowadays it is in growing in the fastest directions. AI and machine learning integration of GIS as working in nowadays very fastly. Then growth of geospatial AI, deep learning, uh, machine learning techniques are used in using different softwares. Then rise of digital 4D GIS, SDG monitoring, open data ecosystems. All all this data, all these parameters are globally increased in 2025. So this is the graph how the GIS evolved from 1962 to more than 2025, from GIS modules to integrated GIS to desktop GIS, then cloud GIS and big GIS. So it gradually increased in a very rapid direction and rapid speed. Then main data models in GIS. So there are two data models, that is vector data and the raster data we have already discussed. So vector data, what is the vector data? It represents the point, line and polygon, and each special feature is linked to a row in attribute table. So previously we just uh, saw that the attribute data, how this attribute data is look like. And row layer stores each row as a line, includes attribute like name, length, type, these type of attributes in the different column. But in the raster data, it is represent the wall as a grid of cells. So each grid have some informations of the reflectance value of the satellite image. So this image, all these satellite data have minimum cell or minimum grid is there. They use for continuous data, it is elevation or temperature or any satellite image. Database structure is grid storage a image or matrix with metadata. And some important things are there in the spatial data. Geometry, features, coordinates, topology are included. And for attribute data, it is name, ID types, metadata, data about data. Then topology rules, relation between the features, and indexes are there. Then type of GIS database structures, how the structures are there. So geospatial data, generally spatial data, non-spatial data. Then flat file is simple table or CSV, Excel file, text file also used. Non-spatial index, there is no indexing, and suitable for small database. Then relational database system, commonly in GIS, in the commonly used in the GIS, like PostSQL, PostGIS, Oracle Spatial, and the store data in related table using primary and foreign key, and support SQL queries. So different queries are supported with the help of database software. Then object-oriented database stores special object and behavior better for complex data relationships. Then geo database. So nowadays geo database is very much useful because it store multiple file like shape file, other file, pictures, attributes, all data can be stored in a single geo database. So it is the form of .gdb. Two type of database is there, that file geodatabase and personal geodatabase. So file geodatabase have lot larger memory, but personal geodatabase, I think it's memory up to 2 GB. More than 2, if we have more than 2 GB, then we will have to store in file geodatabase. Then enterprise geodatabase, so store in RDBMs as well. So these are the GIS based geodatabase. Then raster, what is raster and raster advantage and disadvantage? Raster data made of a pixel each has a specific value often used for continuous data like satellite image, elevation, temperature, NDVI. What is the advantage of the raster data? It is a simple data structure. It is easy to analyze, ideal for continuous data like rainfall data, elevation, temperature, efficient for complex spatial analysis, especially overlay and terrain analysis, and compatible with remote sensing imagery like satellite, aerial data. It is fast processing for large data set, especially with modern hardware. So basically, we use largely raster data and data set in the Google Earth engine for processing on different land use land cover mapping or NDVI calculations. So different calculations are used mostly the raster data sets. Then disadvantages are is a large file as compared to the vector data with especially with high resolution. So high resolution data have more memory and low resolution data have less memory. Then loss of details, fixed cell size may generalize fine tune. So we cannot fine tune this data. So in this image we can look like this is the road. So we cannot fine tune this data as it is a pixel based. In the vector data we can fine tune, we can create, or we just edit this edge. But as it is a pixel based, we cannot fine tune this data. So less visually appealing, not as clean and vector map. Vector are very clean maps as compared to the raster data, and require sampling for scale change. So for different sampling, different scales are there. Then topological relations are harder to represent. Connectivity, adjacence, it takes some complexity in the raster data. Then these are the vector data point line polygons. Vector data represents the point line polygon with road, boundary, and land use. And some advantages are high precision, accurately represent boundaries and say smaller file size, very small. For one, for total village of a one district, with it takes I think 1 MB or 500 KB memory. Then better cartographic output, cleaner and sharper visuals due to uh, not present of the pixel related informations. Then topographical relations are maintained, important network analysis, road, river, then easier to attach attribute data. So in this point line polygon data, we can easily add some attributes of information with the help of primary and foreign keys, which is common. So based on the ID, common ID, we can just join other information with this vector data. Then complex data structures, disadvantages is more difficult to analyze and manage. So if lot of data are there, then it is difficult to analyze. Not suitable for continuous data. Poor at modeling. So modeling purpose of temperature, it takes some difficult stages. Then processing can be slow. Overanalysis is more complex. Interpolation needed for surface modeling. So some of the disadvantages are also there. Now this is the picture of raster data, which is this is a drainage network map, which is created by the supervised classifications of the raster data, and it looks like some it's not clean, but it is a vector data. It is a very clean and neat and clean informations are there because we just draw these lines with the help of point line polygon. That's why it's a neat and clean data. This is the real world. So in this real world, we can create different land use with the help of vector data. This is the vector data polygon, and this is the raster data polygon. So how this two type of data looks like, it is a pixel based or it is not a pixel based. That's why there's a smoothing is seen in the vector data, But in the raster data, it's not smooth as compared to the vector data. So this is like this. In the point file, it is point. Then for line, it is the line that is very smooth line, and in the pixel, it is not smooth. And in the polygon features are there. This is the same polygon. So it is a restricted to the pixel. So it is not restricted to the pixel. This is the difference between the raster and vector. Why we use raster? Because a lot of satellite data have a lot of information about the features. So we just create some different theme with the help of this raster data. Then a lot of applications are there out of this GIS software. So we can use this different spatial analysis using R. R is one of the software. In this software, we can create this platform and different tools like ggplots, rgdel, and INLA. A lot of tools are there. So within with using this tool, our software create different geospatial analysis. Then Python software is also one of the software where GeoPanda package is there. In this package, there is ArcPy, Seaborn, SCPy, TensorFlow. All these tools are used for the operation of different geospatial analysis. Then PostGIS is one of the programming software. So it is basically for database and different other desktop based or graphic based softwares are there. Map API, QGIS, E3, Tableau, Google Earth, Geospark, Oracle, AWS. So a lot of platforms are there. So nowadays GIS uses not only the different customized software or any graphical user interface software, but it is also uses different programming software like Python, R, Java, SQL, PostGIS. So these are the programming software. So in this programming software, we just use satellite image or geospatial data for analysis of our work with the help of machine learning techniques or AI, artificial intelligence. So nowadays the artificial intelligence evolving with the help of this programming. So after that we just discuss some questions answer. And the first question is GIS capture and analysis which type of data? It is both the spatial and geographic data. Then GIS represent unrelated information of location using key index. Which of the following parameter using GIS are correlated to represent Earth's physical location? So which is related to the Earth's physical location? That is spatial and temporal. Space-based information, that was spatial, and temporal means time related. GIS was coined by Roger Tamilson. So first the GIS is coined by the Roger Tamilson, and he is also called as the father of GIS. This is the picture of the Roger Tamilson, sir, it's born in 1933 and this passes away in 2020, 2014. So according to him, uh, he contribute a lot in the GIS field. And which of the following are the digital data creation method? So Ortho-rectification imagery is not the right answer. Digital data creation based on the digitization. We just digitize all the information in the form of shape file or KML file or other file. So this is the answer. What is the function of geoprocessing? So geoprocessing means manipulate the spatial data. Then GIS accuracy depends on the encoded process, source data, both A and B, or locations. GIS accuracy depends which it depends on the source data and the encoded process. So the answer is C. Which of the following are the types of aerial photography? So aerial photography generally capture the data in the two different way, that is oblique or vertical. Generally in vertical way it also capture, and in horizontal way also sorry, in oblique way and vertical way. Horizontal, there is no any data, satellite data, or any um, um, aerial photography in the horizontal way, so it is only both A and B. So likewise these are the some answer of some short questions related to the GIS or basic of GIS. Then we will discuss all other factor of the GIS and different applications and different processing and techniques are there. We will discuss tomorrow. Okay, then we will conclude this season today. Is there any question?
Thank you, sir. Thank you very much. Sir.
Thank you.